All right, so on number 9, there's really not a clever way to solve number 9. It's not multiple choice. The only other way that you could really skirt the issue is by plugging in random numbers for x until you make it spit back a 50, all right? Or something really close to 50, which is doable. The right way to solve this is to take the log of both sides. So you're going to take the log of 4,000 over 5 to the x. We're going to wrap them both in a log. On the left-hand side, because we have a division statement, right, it's going to separate out into 2 logarithms with a subtraction. So it's going to give us log of 4,000 minus log of 5 to the x. We can go ahead and bring down that exponent. It's going to be x log 5. Okay, since we're solving for this x here, we need to get rid of the log 4,000 and then get rid of the number attached to the x. Okay. So we're going to subtract log 4,000 from both sides. That'll give us negative x log 5 equals log 50 minus log 4,000. Okay. Then we're going to divide by the stuff that is attached to the x here. We're going to divide by the negative and the log 5. Negative log 5. Divide by negative log 5. Okay. And so whatever this comes out as, that will be our answer. All right, alpha y equals log 50 minus log 4,000 over negative log 5. There we go. 2.722. All right, and once you get your answer, go ahead and store it to the x and plug that thing in. Make sure that you get 50 whenever you plug in your answer. 4,000 over 5 to the x, and that gives you 50. If you round it here, you won't get exactly 50, but you'll get something close to 50. Okay. Number 10, condense this down into a single logarithm. Okay, so when you're condensing, you want to use these rules. Like you have stuff like this, but you want to rewrite it in this form. All right, you're going to be using these rules backwards, so to speak. The first thing we do is anything that has a number on the outside, like a coefficient, we're going to put back in as an exponent. So this is going to become log 3 to the third plus, this one we'll put back in. It'll be log x squared minus log 4y. Okay. I know they're being multiplied. We could separate it out like this, but we don't want to do that. We're trying to condense it down to 1 log, so we're going to leave it alone like that. Okay, 3 to the third is 3 times 3 times 3, which is 27. Okay, I'm going to put these two together. They're connected by addition, so it's going to be log 27x squared. When we put them together, they get put together by multiplication. Log 4y. And then now, since these are separated by subtraction, they are going to come together using division. All right. It'll be this one right here. It'll be 1 log, and then this is our top one, this as our bottom one. Now, the other way that you could go about answering this question if you didn't know how to actually condense logs, which is okay, is you could just pick some number for x and y on this original expression. The idea is that this is equal to one of these for all values of x and y. So usually our popular random numbers that we use, I'll use like 2 for x and I'll say 3 for y. And I'm just going to type in this expression to see what I get. Okay, let me scroll up here. I'm going to start off with 3 log 3. 3 log 3 plus 2 log x, but I'm going to plug in 2 for the x, minus log, and that's 4 times 3, 4 times y. There you go. So I get 0.9542 out of the original, and then I would come down to these answer options and see which one gives me the same answer. It's going to be option C, right? So log 27 for x squared, we're going to do 2 squared. So 27 times 4 there. And then 4 times 3 will be 12. And it gives us the same answer. Okay, number 11, to answer this, what are we going to do? We're going to use, the simplest way would be to use this change of base formula right here. It would just be log 2 over log 8, and that will give us our answer. Okay. Log 2 divided by log 8, and that's going to give us 0.33, which is the same as 1/3. Okay, and that's because if you do 8 to the 1/3 power, you're going to get 2 back as an answer.